Hi dear students, a very pleasant good morning to one and all. Today we are going to discuss Chapter 8 of Grade 10, that is Introduction to Trigonometry. This chapter, Introduction to Trigonometry, is a very important and interesting chapter. Without much introduction to this chapter, let me go into this topic, that is Introduction to Trigonometry. It is applied in a right angle triangle. Okay, trigonometry is always applied in a right angle triangle. We know what's a right angle triangle, isn't it? A triangle with one of the angle is 90° can be called as a right angle triangle. So here we have 90° angle, so we can name it as triangle ABC. The side opposite to the 90° is called a hypotenuse. Okay, so this is the opposite of the side opposite to the angle. So this side is called hypotenuse. Okay, and the side opposite to the 90°, that is hypotenuse, will be the longest side of a right angle triangle. Okay, now we will discuss about the remaining sides of the triangle. Before that, let me discuss trigonometric ratios. Trigonometric ratios. We have 6 trigonometric ratios. Which are they? Sine, cos, tan, cosec, sec, and cot. The 6 trigonometric ratios are sine, cos, tan, cosec, sec, and cot. Okay, now to apply this in trigonometry, we will consider one of the angle of this triangle except the 90°. So either angle A or angle C can be considered. So we will focus at angle A. So sine A, we are focusing at angle A of the triangle. So that is sine A, cos A, tan A, cosec A, sec A, and cot A. Now we will look into its definitions. What is the definition for sine A? For to know sine A what it is, we first need to focus here. This is the angle that we are focusing at in this triangle. So sine A, so the adjacent side, the closer to the angle A, the side closer to the angle A, that is the adjacent side, isn't it? So this side we can name it as what? Adjacent side. And the side opposite to the angle A, that is opposite side. Okay, so we now learned the 3 sides of a right angle triangle, that is the side opposite to 90°, that is called hypotenuse, the side adjacent, the side closer to the angle which we are focusing at, that is called a adjacent angle, and the side opposite to the adjacent angle or opposite to the angle which we focus at is opposite side. Okay, so opposite side, adjacent side, and hypotenuse. So when we look into the definition of sine A, we can say that sine A, that is what? Opposite side by hypotenuse. Okay, that is opposite side by hypotenuse. The definition for sine is opposite side of the right angle by hypotenuse. Now the definition for cos. What is cos A? So cos A, it is what? Adjacent side by hypotenuse. Okay students, cos it is adjacent side by hypotenuse. Now what about tan A? The definition for tan A, it is opposite by adjacent. Okay, opposite side by adjacent side is what? Tan A. So that is what? Opposite by adjacent. Hope it is clear for you, isn't it students? So now sine A, the definition for sine, it is opposite by hypotenuse. Cos it is adjacent by hypotenuse. Tan it is opposite by adjacent. This must be very thorough. Okay, now when we look into the next 3, that is cosec, sec, and cot. What is cosec A? Cosec A, it is, the definition for cosec, it is hypotenuse by opposite. Okay, the definition for cosec it is hypotenuse by opposite side. Now the definition for sec, what is the definition for sec? It is hypotenuse by adjacent, that is hypotenuse by adjacent side of the right angle triangle. That is the definition for sec A. Now what is the definition for cot A? Cot, it is what? Adjacent by opposite. Cot, it is adjacent by opposite. Okay students, now we discussed the definition for all the trigonometric ratios. We have 6 trigonometric ratios, which are the sine, cos, tan, cosec, sec and cot. Okay, now when we consider a triangle and when we focus its angle, if it is A, we can say that sine A, cos A, tan A and so on. Okay, now the definition for each trigonometric ratios, we can say what it is. Sine A, what is sine A? That is opposite side by hypotenuse. What is cos A? That is adjacent by hypotenuse. What is tan A? That is opposite by adjacent. These trigonometric ratios and its definitions, it must be very thorough. Okay students, so once if you learn this, along with this we can also say that cosec A, that is inverse of sine A. Cosec A is inverse of sine A. Why? Because sine, it is opposite by hypotenuse. Opposite by hypotenuse. When we look into cosec, what is cosec? It is hypotenuse by opposite, isn't it? Just the inverse of sine function. Here it is opposite by hypotenuse. For cosec it is hypotenuse by opposite. Hope it is clear. So sine and cosec it is inverse functions. Similar way, cos A, its definition is what? Adjacent by hypotenuse, isn't it? So its inverse function is sec A, that is what? Hypotenuse by adjacent. Is it clear students? So cos and sec are inverse functions. Adjacent by hypotenuse, its inverse, hypotenuse by adjacent. Okay, now when we look into tan A, that is opposite by adjacent, opposite side by adjacent side. Okay, so its inverse is cot. The inverse of tan is cot, that is opposite by adjacent. Here when its inverse comes, it is adjacent by opposite. Hope it is clear. Okay students, so we just need to remember only this much, that is inverse of sine, it is cosec, inverse of sec, it is cos, inverse of tan, it is cot. Okay, so today we have discussed trigonometric ratios. Trigonometry is discussed, is explained, can be introduced in a right angle triangle where the sides are mentioned as the longest side, that is opposite to 90 degree, that is the hypotenuse, and the side which is closer to the focused angle, that is adjacent side, and the side which is opposite to the angle, that is opposite side, isn't it? So when we look into this definition of this trigonometric ratios, we have 6 trigonometric ratios, that is sine, cos, tan, cosec, sec and cot. When we look into its definition, sine, it is what? Opposite by hypotenuse. Cos, it is adjacent by hypotenuse. Tan, it is opposite by adjacent. Cosec, it is hypotenuse by opposite. Sec, it is hypotenuse by adjacent, and cot, it is adjacent by opposite. Okay, and these trigonometric ratios are inverse functions of the other, that is inverse of sine, it is cosec, inverse of cos, it is sec, and inverse of tan, it is cot. Hope it is clear. You must be very thorough with this. If it is learnt well, practiced well, this chapter is going to be very easy. Hi students, please look at this question. If tan A equal to 4 by 3, find the other trigonometric ratios of angle A. In the question it is given tan A equal to 4 by 3 and we are asked to find the other trigonometric ratios. Which are the other trigonometric ratios? Sine, cos, cosec, sec and cot, isn't it? In the question it is given that answer given tan A equal to 4 by 3. Okay, we have to find the other trigonometric ratios. For that, first we will draw a right angle triangle roughly. Okay, a rough right angle triangle. ABC. It is given tan A equal to 4 by 3, isn't it? By definition, tan, it is opposite by adjacent, isn't it? By definition of tan, we have studied it is opposite by adjacent. So 4, it is a measure of the opposite side. So here we get opposite of A, that is here, isn't it? So here we can mark 4, and 3, that is a measure for adjacent side. Tan A, here it is A, so its adjacent side it is 3. Now to find the other trigonometric ratios, that is sine, cos, cosec and all, we have to know the length of the side hypotenuse, isn't it? That is AC. To find AC, we apply Pythagoras theorem in the triangle. Pythagoras theorem. What is that? To apply Pythagoras theorem, what we do is the length of the longest side, that is the square of hypotenuse. Square of hypotenuse will be equal to sum of the squares of the other two sides, that is AB square plus BC square. Okay, the length of the longest side, its square, the square of the length of the longest side will be equal to sum of the squares of other two sides. This is called a Pythagoras theorem. Okay, so this theorem we will apply in order to find the unknown side of a right angle triangle. Okay, so here AC square we have to find equal to AB. It is given AB is what? 3, isn't it? So AB square it will become 3 square plus BC, it is given BC is given 4. So BC square it will become 4 square. Okay, so that is what? 3 square it is 9 plus 4 square it is 16. That is what? Sum up to 25. Okay students, so now we got AC square equal to 25. We have to find AC, isn't it? So therefore AC equal to root of 25. That is what? Root 25 is 5. So that we can write over here. So AC we got. Now we got all the three sides of the triangle ABC. To find the remaining, the question is find the other trigonometric ratios, isn't it? What are the other trigonometric ratios? That is sine A, cos A, cosec A, sec A and cot A, isn't it? We can find it easily. What is sine? By definition, sine A, it is what? Opposite by hypotenuse, isn't it? By definition, sine A, it is opposite by hypotenuse. So we can write there, it is opposite, it is 4, by hypotenuse it is 5. Okay, cos A, how can we find cos A? By definition, cos, it is adjacent by hypotenuse, isn't it? So here we can write cos A, it is what? Adjacent side, that is 3, by hypotenuse it is 5. Now cosec A, that is inverse of sine, isn't it? Inverse of sine means sine it is 4 by 5. So inverse of sine it is 5 by 4. That's it. Okay, sec A, that is inverse of cos. Cos it is 3 by 5. So sec it will be 5 by 3. Cot A, cot it is inverse of tan, isn't it students? So that is tan it is 4 by 3. That is equal to, therefore cot it will be 3 by 4. Okay, so these are the remaining trigonometric ratios which we are asked to find. Hope it is clear. Now please take it to your notebook students. We will discuss exercise 8.1 now. Okay, thank you.